For decades, astronomers have searched for signs of extraterrestrial life in objects originating outside our solar system. It has been a labor of love and fascination for many scientists, even when the search yielded nothing remarkable for years on end. Yet, it is often when hope is nearly exhausted that the most astonishing events occur. That is precisely what happened recently, when two mysterious objects from beyond our solar system arrived simultaneously, each one sparking both scientific wonder and questions about the possibility of life beyond Earth. The discovery of these objects set off a worldwide scientific collaboration, with scientists from institutions like NASA and SETI joining forces to investigate these enigmatic visitors. What secrets might they hold? Could they provide clues about life beyond our solar system? The first sighting occurred when a Hawaii-based space observatory detected a barely visible object moving through space at a remarkable speed. When scientists traced the object's trajectory, they found it likely originated from Vega, a prominent star situated about 147 trillion miles away from us. Vega, one of the brightest stars in our sky, is located in the constellation Lyra and has long captured humanity's attention as a potential site for planets and extraterrestrial life. The object, which scientists initially described as cigar-shaped and roughly 1,000 meters long, wasn't particularly large by cosmic standards. However, its shape and speed set it apart from the typical comets or asteroids we observe in our solar system. By the time astronomers observed this object, it had already passed by our Sun. To their surprise, it made an unusual maneuver, taking a sharp turn that sent it speeding in another direction. Such behavior is unheard of for natural objects like comets or asteroids, which tend to follow predictable, gravity-driven paths through space. Comets are propelled by the release of gases and ice as they near the Sun, while asteroids typically maintain steady, gravitationally influenced orbits. Yet, this object was different, and astronomers were left scratching their heads over the sudden, controlled-looking turn it took. As scientists were still reeling from the initial discovery, another event occurred. In Crimea, amateur astronomer Gennady Borisov spotted an unusual object moving across the pre-dawn sky. Borisov, who had built his own telescope, observed the object traveling in a direction opposite to that of the comets in our main asteroid belt. His discovery became the second interstellar object to visit our solar system. The arrival of two interstellar objects, especially in such close succession, was unprecedented and thrilling for the astronomical community. These discoveries led scientists to ask, are these visitors natural or possibly artificial? Could they be evidence of intelligent life beyond our understanding? To find answers, scientists looked to the behavior and physical characteristics of the objects. The first object was given the Hawaiian name, Oumuamua, which means scout. This name captures the sense of it being a messenger from afar. Vega, the object's suspected origin point, is an especially notable star. It was once our North Star and will become so again in about 12,000 years due to the Earth's axial wobble, which causes our perception of north to shift gradually over a 26,000-year cycle. Intriguingly, in 2013, astronomers discovered an asteroid belt around Vega, suggesting it could have planetary systems similar to ours. It's possible Oumuamua was one of the objects in this region, flung into our solar system on a cosmic journey across the stars. Unfortunately, scientists could only observe Oumuamua for 11 days, as it was traveling at a speed 3 times faster than Earth's orbit around the Sun. Once it left our solar system, it was too dim to track. During the short time astronomers could monitor Oumuamua, they found it followed a hyperbolic trajectory, which usually indicates an object influenced only by gravity. Yet this object didn't just follow gravity's pull, it accelerated as if pushed by an unseen force. Scientists were puzzled. Typically, comets experience bursts of acceleration when they release gases as they heat up near the Sun. However, Oumuamua showed no such signs, no tail, no visible gas emissions. Its acceleration was smooth and controlled, unlike anything scientists had previously observed. The object's acceleration, coupled with its cigar-like shape, led to intense debate among scientists. Harvard astronomer Avi Loeb proposed a bold theory. Oumuamua might be an artificial structure, potentially sent by an intelligent alien civilization. This theory attracted both curiosity and skepticism. In the years since its discovery, Oumuamua's unusual behavior and shape have fueled discussions about whether it could be a probe sent to study other solar systems, potentially ours. As it passed its closest point to the Sun, Oumuamua sped away at a remarkable 95,000 kilometers per second, easily breaking free of our star's gravitational pull. On October 7, 2017, it was last observed heading toward the constellation Pegasus, on an unknown journey beyond our reach. Without close-up photos or additional data, scientists could only speculate on its true nature. Some researchers believe it could be a spacecraft with a light sail, which would explain its steady acceleration. Others remain more conservative, viewing it as an unusual but natural object. While Oumuamua's silence in response to radio signals dampened hopes of finding intelligent life, scientists kept searching. With the Green Bank Telescope in West Virginia and the Allen Telescope Array in California, they monitored Oumuamua for signals, but none were detected. The second visitor, now named 2I/Borisov after its discoverer, turned out to be easier to understand. It exhibited characteristics of a typical comet, with a visible tail and a composition of water, dust, and carbon monoxide. This mix of materials is similar to the makeup of comets in the outer regions of our solar system, giving scientists a solid basis to classify it as the first interstellar comet. 2I/Borisov's arrival made Oumuamua appear even stranger by comparison. The comet is believed to have originated from a red dwarf star, a dim and common type of star in our galaxy. Some scientists, examining its trajectory, hypothesized that it might have been ejected from a distant star system, possibly after a collision between massive objects in the area around Ross 573, a red dwarf located roughly 629 trillion miles from our Sun. Estimates suggest this violent event occurred around 900,000 years ago, sending Borisov's comet on a journey across the galaxy. Unlike Oumuamua, 2I/Borisov's tail and composition fit expectations for a comet. Still, its interstellar origin made it remarkable, as it provided the first direct evidence that material from other star systems can pass through our own. In the end, both Oumuamua and 2I/Borisov have deepened our curiosity about life beyond Earth. The mystery of Oumuamua's origin and the possibility it was an artificial probe challenge us to rethink our assumptions. While we may never know the true nature of these objects, their presence sparks our imagination. If advanced civilizations do exist and want to study other forms of life, they might design spacecraft that blend seamlessly with natural objects. Such a device would easily evade detection and avoid arousing suspicion. The discovery of these interstellar visitors opens new chapters in our search for extraterrestrial life. They remind us of the vastness of our universe and the possibility that, somewhere in the stars, other civilizations might be reaching out or simply observing. For now, we are left to ponder the mysteries and wait for the next visitor from beyond.